Hello everyone. In this video we will see how to calculate the total number of functions. This is very important. Nowadays this is a trending topic and this comes under the chapter permutation and combination. Okay. So we have to calculate the total number of functions. So we all know that the function is from set A to B. Then set A is called as the domain set for the function A, and this is called as a codomain set for the function f. Okay, function, the total number of functions also on the basis of the classification of function, the total number of function is total number of onto function plus into function, correct? And also the total number of function is total number of one function plus total number of many one function. So function is either onto function or into function, and onto function and into function combinedly gives the total number of functions. Similarly, one function or many one function. Okay, one function and many one function combinedly gives total function. So this is on the basis of functions only. Now my question is to calculate the total number of function when function is defined from the set A to set B. Set A is the domain set and set B is the codomain set. Okay, definitely the total number of functions, total number of onto functions, total number of into function, one function, many one function. Now all this depends upon the number of elements present in the set A and set B. Okay, so this total number of function, onto function, into function, number of one function, number of many one function definitely depends upon the number of elements present in set A and set B. Okay, so coming to the number of elements present in set A and set B. So there may be the three possibilities if n of A is equal to n of B. Okay, n of A equal to n of B. One possible, either n of A is less than n of B. Second possible case are n of A is greater than n of B. So there are three possibilities for the domain set A and codomain set B having the elements in that way. Okay, both the set can have the same elements, or the domain set have less element than the codomain set, or the domain set have more elements than the codomain set. Now in all these three cases we have to calculate the total number of functions. Okay, number of onto functions, number of one functions, number of many one functions, and like that. Fine. So let's start with the n of A equal to n of B. So when n of A equal to n of B, say n of A equal to n of B, that is equal to 5. So in that case you will have 1 2 3 4 5, that is 1 2 3 4 5, and here A, B, C, D and E. So these are the 5 elements in the set A and set B. We are defining the function from set A to set B, where A is the domain set and B is the codomain set. Okay, then definitely one can take 5 images. Okay, one can take 5 images. Okay, that is, there are 5 ways to take 5 images. There are 5 ways to take image of this function 1 in the codomain set B. Similarly, 2 also has 5 ways to take the images. Okay, similarly 3, similarly 4, and similarly 5. So each element can take 5 images in the codomain set B. So if one is taking 5 images, it means that there are 5 distinct functions. Okay, by each rule, one is associated with the elements of the codomain set B. So therefore, if there are possibilities of one taking 5 images, there means there are 5 distinct functions. So the total number of functions I can calculate now as 5 into 5 into 5 into 5, that is 5 की power 5. This is your total number of functions. Now what we can observe over there, 5 is the number of elements present in codomain set and domain set. Okay, the 5 की power 5. Now this 5 and this 5 is coming from which set? Okay, that is the question. We will solve it by the next example when n of A is less than n of B. Suppose n of A is less than n of B. N of A is less than n of B. That is, we are having 4 elements 1, 2, 3 and 4 in the set A, and in the set B we are having the 5 elements A, B, C, D and E. So these are the 5 elements, correct? This is set A and this is set B. We are defining the function from set A to set B, where A is the domain set containing 4 elements, where B is the codomain set containing 5 elements. So now how many functions we can define over here? So one can take 5 images. Okay. Similarly, 2 can take 5 images. Similarly, 3 and similarly 4. Okay, the total number of function is 5 into 5 into 5 into 5, that is 5 की power 4. Now by observing these two, I can generate the formula, correct? See, 5 is there in the 5 is the number of elements present in the codomain set and 4 is the number of elements present in the domain set. So therefore, from these two I can say that the total number of functions is n of B की power n of A. That is the formula to find out the total number of function from set A to set B, where B is the codomain set, A is the domain set. The number of functions defined from the set A to the set B is given by n of B की power में n of A. Very simple. So similarly here also n of A is greater than n of B. That doesn't matter. N of A is greater than n of B, or n of A is less than n of B, or n of A is greater than n of B. For all these 3 cases, the total number of function is given by this formula only. Correct? Very easy. Number of elements present in the codomain set B to the power number of elements present in the domain set. This defines the total number of functions. Fine. So total number of functions we have defined. The formula we know now, n of B to the power n of A. Now coming to the total number of 1 function. How to find out the total number of 1 function? So here also we will have the 3 cases. First case is when n of A equal to n of B. Second one is when n of A is less than n of B. And third one is n of A is greater than n of B. So from these 3 cases I can easily identify that out of these 3 cases, one case has 0 number of 1 function. 1 function, okay. So देखो n of A is greater than n of B. In that case, you will easily say that this situation there will be no 1 function. See, 1, 2, 3, 4, 5. 1, 2, 3 and 4. So this can go here, this can go here, this can go here, this can go here, but this remains empty, okay, for set A to set B. So whenever n of A is greater than n of B, then the total number of 1 function is 0. This is very clear from the definition of one function only. I can easily find out that the one function over here where n of a is greater than n of b is 0. Correct? So this case is over. Now coming to these two cases when n of a equal to n of b and n of a is less than n of b. Similar way में n of a 1, 2, 3, 4 and 5. This is A, B, C, D and E. This is a set A and this is set B. So one can take the image in 5 ways. Correct? One can go to A or to B or to C or to D or to E. Okay? Now one is fixed. So therefore 2 can have 4 ways now for function to be 1. So 2 has 4 choices. So similarly 3 has 3 choices. 4 has 2 choices and 5 has 1 choices. The total is 5 into 4 into 3 into 2 into 1. That is what 5 ka factorial. So 5 ka factorial is the total number of one function. Clear hai? When n of a equal to n of b. And if suppose that n of a is less than n of b, this is the case. So ये वाला case यहाँ से हट जाएगा. This case we will not have. So one can have 5 images, 2 can have 4 ways to get the image, 3 can have 3 ways to get the image, okay, 4 can have 2 ways to get the image. Still 5 into 4 into 3 into 2, okay, and this is again 5 ka factorial. So the total number of one function is 5 is what? 5 is the number of elements present in the codomain set, whether n of a equal to n of b or n of a is less than n of b. So this is n of b ka factorial. This is the total number of one function, provided n of a equal to n of b or n of a is less than n of b. This case is not there. n of a is greater than n of b. तो यहाँ पे आप ये भी लिख सकते हैं provided n of a equal to n of b and n of a is less than, so this is less than equal to n of b कर दो, less than equal to n of b. That is when n of a is greater than n of b, then the total number of one function is 0. I hope that this concept is also clear. Correct? So once you find out the total number of one function, then you can easily find out the total number of many one function. So how can we find out the many one function? The number of many one function. Total number of function here 5 की power 5 minus 5 का factorial. Correct? This is total number of function and this is total number of one function, and therefore the number of many one function. For this case, when n of a is less than n of b, that will be the 5 की power 4 minus 5 का factorial. जब मैंने यहाँ पे 4 elements लिए थे, कहाँ पे n of a is less than n of b में 4 elements लिए, so that time it is 5 की power 4 minus 5 का factorial. Very simple. So one function is over. Now we will see the total number of onto functions. Now we will see the total number of onto function. Now coming to the very interesting point of the permutation and combination. So here also we will have case 1 when n of a equal to n of b, when n of a is less than n of b, and here n of a is greater than n of b. Okay. So when n of a is less than n of b, n of a is less than n of b, we have seen that when n of a is less than n of b, then here n of a is greater than n of b, the total number of one function is 0. But when n of a is less than n of b, for example here 1, 2, 3 and 4. And this is A, B, C, D and E. So for onto function, this A has to take its pre-image, B has to take its pre-image, C has to take its pre-image, D has to take its pre-image, also E has to take its pre-image. Correct? So A can take the pre-image in 4 ways. Correct? Similarly, B in 3 ways. Okay? Because A cannot take the pre-image 1 and pre-image 2. Correct? Like that, it is not possible. Okay? Just a minute. A can take the pre-image in 4 ways. B can take the pre-image in 3 ways. C can take the pre-image, okay, in 2 ways. And D can take the pre-image in 1 ways. But there is no element remain in the domain set which has its pre-image. Therefore, when n of A is less than n of B, the total number of onto function, the total number of onto functions will be 0. We have to understand this in a different way as well. Okay. Now this is set A and this is set B. In fact, the calculating the total number of onto function is equivalent to the distribution of the objects, distinct objects to the, for example, these are the these are the 4 balls, 4 distinct balls, okay, distinct balls, and these are the 5 distinct boxes, 5 distinct boxes, okay. So these 4 balls has to be put in these 5 distinct boxes in such a way that that each box get at least 1 ball. Then only the concept of the one-to function will be applicable over here. Correct, agree? For an onto function, the range must be equal to the codomain. Okay. So this A, B, C, D, E has their pre-image. Every element of this set B has their pre-image. So therefore, A can take pre-image in 4 ways. Okay. 4 distinct type of onto functions. B can have the pre-image in 3 ways. Okay. And similarly, C can have the pre-image in 2 ways. D can have the pre-image in 1 ways. But E के लिए कोई element नहीं बचेगा. And therefore, the onto functions over here is 0. Now, onto function is equivalent to the concept of the permutation and combination, that the distribution of 4 balls, 4 distinct balls into the 5 distinct boxes such that each box get at least 1. ये at least 1 का concept important रहेगा. At least 1 ball. So I can give 1 ball to this one, 1 ball to this one, 1 ball to this one, 1 ball to this one. But this E will remain empty. It will not get any ball. So therefore, but this is very equivalent to this concept. Okay. So the onto function is equivalent to the distribution of distinct balls to distinct boxes such that each box get at least 1 ball. At least 1 ball. So in that way you can find out the number of onto functions. So therefore number of onto function is not possible or 0 in the case when n of A is less than n of B. So this case is over. Now in these two cases, n of a equal to n of b and n of a is greater than n of b, we will calculate the number of onto functions. So there are 5 elements in the set A and 5 elements in the set B, correct? So the number of onto function is equivalent to, say that these are the 5 distinct balls that has to be distributed into the 5 distinct boxes, so that each box gets at least one, this is important, at least one ball, correct? So I have the 5 balls, I can divide first, give this 1 1 1 1 to each box, okay? If there will be 6, no problem. If 6 balls, that is n of a is greater than n of b, and there are 5 distinct boxes, so therefore be 1 1 1 1 1, this pi is now 6, okay? So I can give one more to the any one of the box, so I can give 2 to this box, or 2 to this box, or 2 to this box, and like that. So these are the way to make the distribution formula I will tell you. So here 5, so therefore the number of ways, 5 means 5 factorial, 1 1 1 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial. How many times 1 has occurred? 5 times. So therefore multiplied by 1 by 5 factorial. And we have to make the distribution that this particular ball can goes to any one of the box, okay? I have given one ball. One ball is distinct, okay? Every ball is distinct. Therefore that particular ball has 5 choices. Either it goes to the box number A, or box number B, or box number C. So therefore here 5 factorial. So this is the total number of onto function. Means you have to make the division. For example, this is 6. Okay, n of a is greater than n of b, then also the total number of onto function is possible, correct? So 1 1 1 1 to each, because every box has to get at least one ball. So I can give one extra ball to any one of the box. So therefore this is 2 factorial for this 2, 1 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial now has occurred how many times? 4 times. Therefore I can multiply it by 1 by 4 factorial, and we have to distribute this to the 5 distinct boxes. Therefore multiplication by 5 factorial. Hope that this concept is now clear, how to calculate the total number of onto function. So the total number of onto function, you can say in this way also, the total number of onto function is equivalent to number of ways of distribution of the distinct objects, okay? Number of ways of distributing of distinct object to the distinct boxes, so that each box can get at least one object. So this is the number of onto function. I hope that now this point is very clear. Once you know the number of onto functions, and number of onto function is not possible in the case when n of a is less than n of b, because यहाँ पे अगर ये कम हो जाए, 4 हो जाए, so I can give, this is 4, so 4 is 1 1 1 and 1, but this is not getting any number, but the condition is that the number of onto function is equivalent to the distribution of distinct balls to the distinct boxes, such that each box get at least one ball. तो यहाँ पे एक भी बॉल नहीं आएगा. So therefore in that case, when n of a is less than n of b, the number of onto function is 0, and when n of a is greater than n of b, then the number of 1 1 function is 0. You have to remember like that, okay? Fine. So this case is also over. One interesting thing regarding the function and permutation and combination, that is the onto function, we have seen that it is equivalent to the distribution of distinct balls to distinct boxes such that each box get at least one ball. Okay, similarly, the total number of function is equivalent to say that the filling of boxes by distinct boxes. That word is very important. Distinct boxes by distinct objects. The number of ways of filling of distinct boxes by distinct objects so that each box can hold all objects. So see here 1, 2, 3, 4 and 5. This is A, B, C, D and E. The total number of function is 5 की power 5. This is your answer, correct? 5 की power 5. And this is equivalent to say that the filling of, these are the 5 distinct boxes. These are 5 distinct boxes. These are 5 distinct balls. Okay, distinct balls. So, I want to calculate the total number of ways of filling the 5 distinct boxes with the 5 distinct balls such that each box can hold all 5 objects is equal to the total number of functions defined from set A to set B. Correct है क्या? Yes. For example, all the 5 balls can go to the box number A. This is a very good constant function. No? Constant function. Okay. Another constant function we can have that all the 5 balls can go to the box number B. So the number of calculating the function. Okay, you can use this concept correctly. So one way of calculating the function, that is the rule which defines that all 1, 2, 3, 4, 5 balls goes to the box A and all 1, 2, 3, 4, 5 goes to the box B is the another function, and like that. Correct? So therefore here you can say that the total number of function from set A to the set B is equivalent to filling of distinct boxes by distinct objects so that each box can hold all the objects. तो आपको permutation and combination का ये वाला problem आया कि 5 distinct balls has to be filled into this 5 distinct boxes. Distinct is very important. 5 distinct boxes so that each box can hold all the 5 balls. Then how many number of ways we can do that? So this is simply the total number of function. For example, here 4. So this will be 5 की power 4. So the total number of ways of distributing the 4 distinct balls, the total number of ways of distributing 4 distinct balls to the 5 distinct boxes so that, this condition is very important, each box can hold all balls, 4 balls. So therefore there will be 5 की power 4 and like that. Okay, so this concept is also over. Now let's do some problems. So these are the 2 basic examples. Now you can understand to calculate the total number of function, total number of one function, total number of onto function, many one function, into function. So first question is find the total number of into function. Okay, into function that can be derived from the set A. To into function A, that means we have to calculate the onto functions. Okay, and then we can subtract the total number of onto function from the total number of functions. So total number of function. First solution, total number of function. Total number of function is n of b power n of a, formula is over. N of b is 3, n of a is 5, 3 की power 5. I think that this is 243. Okay. Okay, fine. The total number of onto function we have to calculate. Now the onto function means equivalent to the distribution of distinct objects. In the distinct boxes so that each box can get at least one object. That is important. Okay, so we are having 5 distinct balls, correct, and 3 boxes are there, so I can give 1, 1 and 1 first, because each box has to hold one ball at least. But there are 5, so remaining 2 I can give, say 1 I can give to here and 1 here. Or this may also possible that 1, 1, 1, 1, all the remaining 2 will go to the one box. That is, so this way we can distribute 2, 2, 1 and 1, 1, 3. Correct? So therefore the number of distribution is 5 factorial. Got it? 5 factorial by 2 factorial, 2 factorial, 1 factorial, 2, 2 has come 2 times, therefore 1 upon 2 factorial. 3 boxes में distribute करना है, मतलब 3 factorial plus, और है तो plus. This case is also there. So therefore 5 factorial, 1 का factorial, 1 का factorial, 3 का factorial, 1 1 2 times है तो 1 upon 2 का factorial, into का 3 का factorial, 3 का factorial by 3 boxes distribute भी करना है. तो ये कैलकुलेट करेंगे, तो ये कितना हो जाएगा, 2 है तो ये 3, 5 फैक्टर 120 इंटू 3, 120 इंटू 3 डिवाइडेड बाई ये बचेगा 4, 4 से ये कितने बचेगा, ये 90 हो जाएगा. सो दैट इज इक्वल टू 90 प्लस, अब इसको कैलकुलेट करते हैं, 3 फैक्टोरियल कैंसिल आउट हो जाएगा. सो देयरफॉर 5 इंटू 4 इंटू 3, 5 इंटू 4 इंटू 3, दैट इज 60. So 90 plus 60, that is equal to 150, total number of onto functions. So the total number of onto function is 150. I want to find out the total number of into function, and that is equal to 243 minus 150. That will be your answer. Hope that this problem is very clear. Now coming to the second one. In that case, find the total number of many one function. Many one function means we have to calculate the one function. And for that, first of all, we have to calculate the total number of function. So the total number of function, that is equal to n of b की power n of a. n of b is 4 or n of a is 3. 4 की power 3, that is 64. Very simple. Okay. Now coming to the total number of one function. इसका भी फार्मूला मुझे मालूम है. दिस इज n of b का फैक्टोरियल, प्रोवाइडेड दैट n of a is less than n of b or n of a is equal to n of b. Correct? This is not true when n of b is less than n of a or n of a is greater than n of b. That is case is over. n of b is 4 factorial, that is 24. Therefore number of many one function is 64 minus 24, that is equal to 40. So this is all about the calculating the number of functions. I hope that you enjoyed this lecture. Thank you.